was a holy moment. The Andromeda Nebula overnight became the Andromeda Galaxy.
The James Webb Telescope has identified 6 galaxies that exist 500 million years after the Big Bang. This is incredible. When you look at the night sky, you have a pinpoint of light. A pinpoint of light in the night sky expanded gives you one of these pictures from the Webb Space Telescope.
Could Proxima b be another Earth-like planet? These are speculations everyone keeps making. The search for an alternative habitable planet and alien life is something that fascinates humans. There have been various speculations, and the fact that signals have been detected from Proxima b makes people believe there is more to it. Despite these signs, we have yet to determine if these are messages from the planet or simply echoes of our own signals. Often, these signals end up being echoes, but scientists hope to determine if they are truly from Proxima b, which could confirm the existence of alien life. Recently, the James Webb Telescope detected artificial lights on Proxima b. If you're interested in learning more about other planets and the progress in finding alternate life, subscribe to our channel. We create content about outer space and discuss innovations in science. If you like this content, comment below and share this video with your friends. Now, let's dive back into our video. Proxima Centauri, located about 4.2 light-years from our solar system, is a faint dwarf star classified as a GV star. This star is known as Proxima Centauri, the closest to our Sun and solar system. It was named Alpha Centauri by Johann Bayer in 1603, derived from the star's ascension at noon, while several celestial bodies like the Moon and the Sun were in a straight line. Proxima Centauri is also referred to as Alpha Centauri or Alpha Centaur. It is part of a single star system with 4 main stars in alignment, and Proxima Centauri is at the center of this system. Alongside the 4 stars, there are 2 faint dwarfs, Alpha Centauri A, also called Rigil Kentaurus, and Alpha Centauri B. These stars contribute to the bulk of the system's mass but are too faint to be seen by the naked eye. This system is located about 23 degrees away from the border of the famous Plough asterism in the constellation Centaurus. Even though Proxima b is a rocky planet, there is hope that it might host extraterrestrial life. The search for other life forms has brought scientists to Proxima b, as its similarities to Earth's size and distance from its dwarf star make it a viable option for supporting life. While these are just speculations, there is hope that there might be some truth to them. There is still much to learn about Proxima b and its orbit, so stay tuned for more information. You can also check out some of our other content related to extraterrestrials. Do you believe there is other life out there? Leave a comment below. What fascinates most people about Proxima b is its similarity to Earth. Studies show that Proxima b is an exoplanet that orbits an M-type star with a mass 1.27 times that of Earth. Proxima b takes 11.5 days to complete its orbit around its star. It was discovered in 2016, and many scientists are still studying it. While Proxima b appears similar to Earth, certain features make it uninhabitable. For one, the planet is too close to its star, resulting in extreme ultraviolet radiation. This radiation is estimated to be hundreds of times stronger than what we receive from the Sun, stripping away light hydrogen molecules over time and doing the same to oxygen and nitrogen. While some may argue that Proxima b should be habitable because it is at a similar distance from its star as Earth is from the Sun, there is more to consider. Distance alone does not guarantee the presence of water or an atmosphere conducive to life. Earth's atmosphere is what makes it habitable, not just its distance from the Sun. The right atmosphere enables climate regulation and a water-friendly surface while shielding living organisms from hazardous space weather. If you're with us so far and haven't subscribed yet, take a second to hit the subscribe button. It helps us keep creating content like this that you'll enjoy. Now, let's explore why people think the James Webb Telescope will help us determine if there is life on Proxima b. The James Webb Telescope was launched in 2018 after being delayed since 2011. Many changes were made to ensure it provided accurate images. Loeb explained that if a planet like Proxima b could absorb light from its star, it could also re-emit it as infrared light. The James Webb Telescope was specifically designed to observe infrared light. It can take photos of this light on a planet's surface and look for patterns that could confirm the presence of water or an atmosphere. One reason space telescopes are preferred over ground-based ones is that, being above Earth's atmosphere, they don't have to peer through shifting air, providing a clearer view of deep space. This allows them to observe what ground telescopes cannot. Additionally, space telescopes are not affected by weather changes on Earth, ensuring clear readings. However, the downside of space telescopes is that repairing them is expensive. If something goes wrong, an entire mission into space may be required to fix even a small flaw, which can be costly. Observing planets like Proxima b is difficult with the James Webb Telescope, and there is no option for rescue if something goes wrong, since it has been launched over 1.5 million kilometers away, further than any human has ever traveled. Rescue missions are not an option. The James Webb Telescope comes with a larger mirror, allowing us to see way back to the beginning of the universe, almost 13.7 billion years ago. The further away an object is, the further in time we get to see it. This happens because it takes a while for light to travel from an object back to us. The ability of the James Webb Space Telescope to see the universe in a longer wavelength in infrared light means we get to see more distant galaxies in our universe with more certainty than was previously possible. Therefore, observing planets like Proxima b has become easier, and it has pushed the light out of the visible range and into the infrared. Tabor and Loeb have a scale of artificial illumination as a fraction of how the sun illuminates and reflects on the day side of the planet. At 0% on the scale, one would assume that the planet's night side is completely dark with no illumination. At 100%, it means that the planet's night side is just as bright as the day side. There has been speculation about a hypothetical civilization on Proxima b using this type of light, and most scientists believe it is similar to the early days on Earth. The studies show that if the night side of Proxima b reaches an illumination of 5% of the natural day side, then the James Webb Telescope could detect the artificial light by 85%. If the illumination reached 9%, the telescope would detect up to 95%. Even though 5% illumination sounds like a small number, we're talking about the light from a star as far away as Proxima Centauri, which is 20,000 times dimmer than our sun, yet we still have a lot of light from our star. This means that even at 0.01% of illumination, we are still reflected in the stellar illumination. In other words, if Proxima b has any civilization disguised as glowing like Earth, the James Webb Telescope would not detect it. The stars would need to be about 500 times brighter. This scenario is impossible since Proxima b orbits so closely to its host star that it might be tidally locked, meaning one side of the planet always faces the star while the other is in perpetual night. A civilization living on a tidally locked planet might need to focus on illuminating infrastructure and use very bright orbital mirrors to reflect sunlight from the day side to the night side of the planet. All these are speculations made by Tabor and Loeb, and there is yet to be proof to show that it is true. Earth's illumination can be seen from outer space and is known as airglow. Most people wonder why the world is surrounded by bright shades of red, yellow, green, and purple light when viewed from 300 miles above its surface. The airglow happens when atoms and molecules in the upper atmosphere produce light to release excess energy. On Earth, the airglow can occur when atoms and molecules get ionized by sunlight and capture free electrons. The glow seems similar to an aurora, except that auroras are driven by high-energy particles from the solar wind, while the airglow is driven daily by solar radiation. Since the James Webb Telescope's launch, scientists have been asking whether it is sufficient to view other planets in faraway galaxies. Even though it is the furthest satellite telescope launched, it still provides very little data needed to find planets with life in other galaxies. As such, there have been conversations about developing bigger and better telescopes. These ventures are often costly and involve a lot of trial and error. The James Webb Space Telescope launch was 7 years late due to these issues. Therefore, it is challenging for most scientists to develop better innovations that can be launched further into space. Despite this, the James Webb Space Telescope's results are promising, and soon we might know if there is life on Proxima b and other planets. While work is still being done on more telescopes, it is believed that the completion and launch of the Habitable Exoplanet Observatory, HabEx, will revolutionize space study. The estimated completion time of HabEx is 2035, with a launch soon after. HabEx will be sensitive to all planets in the universe, although its main objective is to search for Earth-like planets. Its advanced technology will enable it to measure the spectra of most planets and determine if they are habitable. HabEx is also believed to have a broad range of astrophysics capabilities, enabling it to study the earliest possible times in the universe's history, gather information, and understand the life cycles and deaths of massive stars, as well as the elements that support life as we know it. Even though HabEx is still in manufacturing, the technology used to make it will allow it to study Earth-like